In module 2 of chapter 2, we shall study homogeneous Fredholm integral equation of second kind. Here we shall learn how to solve, that means to find out non-trivial solution of homogeneous Fredholm integral equation of second kind with degenerate kernel. We consider the homogeneous Fredholm integral equation of second kind with degenerate kernel as given by this equation. Here the kernel kxt is degenerate and has the form given here. AIX and BIT, as stated before, are two linearly independent finite set of continuous functions. It is obvious that phi x equal to 0 is a solution of this homogeneous Fredholm integral equation. But we are not interested in trivial solution. We shall seek non-trivial solution of this homogeneous Fredholm integral equation of second kind with degenerate kernel. We shall now consider some example. Example 1, we will solve the Fredholm integral equation given by equation 2.32, where the kernel kxt is given by the product of two functions gx and ht, where gx and ht are continuous functions. To solve equation 2.32, we substitute kxt in this equation 2.32 to get the equation 2.34. This equation 2.34 can be alternately written as given by equation 2.35. We write gamma equal to the integral from a to b ht into phi t dt as given by equation 2.36, so that if I substitute in place of this integral the constant gamma, then this equation 2.35 becomes phi x equal to lambda into gamma into gx as given by equation 2.37. Now we substitute phi x from equation 2.37 into equation 2.36 to obtain gamma equal to lambda gamma into alpha, where alpha is a constant given by equation 2.39. The relation 2.38 can be written in the form as given in this equation. From this equation, we note that if 1 minus lambda alpha is not equal to 0, then this constant gamma has to be equal to 0. If I now substitute gamma equal to 0 in the equation 2.37, then I get phi x equal to 0. That means the integral equation in its homogeneous form of second kind with degenerate kernel in this example has only trivial solution. But we are not interested in trivial solution. We would like to find out the non-trivial solution. If 1 minus lambda alpha is equal to 0, then gamma is not equal to 0. That means for lambda not equal to 1 by alpha, we have obtained already gamma equal to 0. But for lambda equal to 1 by alpha, gamma is not equal to 0 and it is an arbitrary constant. So, if gamma is an arbitrary constant, then from equation 2.37 we obtain the non-trivial solution phi x of the given integral equation as given by this equation, where gamma is arbitrary constant. Thus, in this example, for certain value of lambda, we could obtain non-trivial solution of the given homogeneous integral equation. Next, we consider example 2. In this example, we are to find out the non-trivial solution of homogeneous Fredholm integral equation of second kind, where the kernel is cos x minus t as given by equation 2.40. We expand this function cos x minus t and rewrite the given integral equation 2.40 in the form as given here. Now, considering this function as gamma, that is, it is a constant, and this constant, that is this integral, as another constant gamma 2, we can alternately write this expression in the form given by equation 2.41, where gamma 1 is given by equation 2.42 and gamma 2 is given by equation 2.43. If somehow we can know gamma 1 and gamma 2 as non-zero constants, then we will get non-trivial solution of the given integral equation 2.40. To know this, we substitute phi x from equation 2.41 into equation 2.42 and in equation 2.43 and simplify to obtain the following homogeneous linear equations in gamma 1 and gamma 2 as given by equations 2.44 and 2.45. We see that both equations 2.44 and 2.45 imply that for lambda equal to 1, gamma 1 and gamma 2 are arbitrary constants, whereas for lambda not equal to 1, gamma 1 and gamma 2 they are 0. If gamma 1 and gamma 2 they are 0, then we get from equation 2.41 only the trivial solution of equation 2.40. So, for lambda equal to 1, if gamma 1 and gamma 2 are arbitrary constants, then we substitute gamma 1 and gamma 2 in 2.41 to obtain the non-trivial solution of the given integral equation in this form. Here gamma 2 and gamma 1 are arbitrary constants. Next, we consider the integral equation given by equation 2.46. This is also homogeneous Fredholm integral equation of second kind whose kernel is degenerate kernel. We shall seek non-trivial solution of this homogeneous integral equation given by 2.46. We rewrite equation 2.46 in the form given by this equation. Writing for this integral as gamma 1 and for this integral as constant gamma 2, this expression can be alternately written in the form given by 2.47, where gamma 1 and gamma 2 are the constants given by equations 2.48 and 2.49. Next, we substitute phi x from equation 2.47 into equation 2.48 and equation 2.49 to obtain the following two homogeneous linear algebraic equation in gamma 1 and gamma 2 as given by equation 2.50 and 2.51. This system of linear equation will have trivial solution if the determinant of the coefficient matrix given by this is not equal to 0. Expanding this determinant, we obtain lambda not equal to 1. So, for lambda not equal to 1, this system of linear equation will have trivial solution and the corresponding integral equation will also have trivial solution. But we try to seek non-trivial solution. So, for lambda equal to 1, we obtain from equations 2.50 and 2.51 the value of gamma 1 and gamma 2 in terms of an arbitrary constant m1. If I substitute m1 into equation 2.47 in place of gamma 1 and gamma 2, we find the non-trivial solution of the given integral equation as phi x equal to m1 into 1 minus x by 2. So, this is the non-trivial solution of the given integral equation. So far, we have considered few examples where we have obtained non-trivial solution of homogeneous Fredholm integral equation of second kind with degenerate kernel for only one value of the parameter lambda. We now go to example 4 and see how to find out the non-trivial solution of the homogeneous Fredholm integral equation and what are the solutions. In example 4, we consider the homogeneous Fredholm integral equation as given by equation 2.53, where the kernel is sin x plus t. We expand this function sin x plus t to rewrite equation 2.53 in the form given by this equation. This equation can be alternately written in form of equation 2.54, where gamma 1 is the integral given by 2.55 and gamma 2 is another integral given by 2.56. Here gamma 1 and gamma 2 are constants. As before, we substitute phi x from equation 2.54 into equations 2.55 and 56 to obtain the system of linear equations in gamma 1 and gamma 2 as given by 2.57 and 2.58. This system has trivial solution if the determinant of coefficient matrix of the linear system 2.57 and 2.58 is not equal to 0 as given in equation 2.59. So, for lambda not equal to plus minus 2 by pi, we see that the system of equation 2.57 and 2.58 has only trivial solution. In that case, the given homogeneous integral equation will also have only trivial solution. Now, for lambda equal to plus minus 2 by pi, we expect non-trivial solution of the system of equation given by 2.57 and 2.58. For lambda equal to 2 by pi, we have from this system of linear equation gamma 1 equal to gamma 2 equal to some arbitrary constant m2, say. Hence, if I substitute gamma 1, gamma 2 equal to m2 in the equation 2.54 in place of gamma 1 and gamma 2, we obtain the non-trivial solution of given integral equation in this form. Here m2 is arbitrary constant. In the next case, when lambda equal to minus 2 by pi, we obtain from the system of equations 2.57 and 58 that gamma 1 equal to minus gamma 2 and each is equal to some constant m3, say, where m3 is an arbitrary constant. So, substituting gamma 1 and gamma 2 as in terms of m3 in equation 2.54, we get the non-trivial solution for lambda equal to minus 2 by pi as given by phi x equal to minus 2 by pi m3 into sin x minus cos x. Here m3 is an arbitrary constant. So, we have found out non-trivial solution of the given integral equation for two values of lambda equal to plus minus 2 by pi. In this module, we have learned how to find out non-trivial solution of homogeneous Fredholm integral equation of second kind with degenerate kernel for certain values of the parameter lambda. So, this parameter lambda plays an important role for existence of non-trivial solution of homogeneous integral equation of second kind.